Good morning, everyone. Okay, your teacher had some emergency today. All right, that's why I start with the class. Okay, all right, so, all right, now I do this one. Okay, your teachers want to do this one. Okay, dilation. All right, okay. Now take a look. I'm not gonna go right fast. Okay, I just go slowly, but I want you to figure out completely, okay, the topics. Okay, yeah, that is very important. So I'm going to take a look. Today's dilations. Okay, dilation means what? Change to size, but not shape. Same shape, but change the only size. Okay, that is dilation. So we have two different dilation there. Okay, one is enlarged. You can see it over here, enlarged. The other one is reduce or shrink. You use it, this is better, shrink. Shrink is a small size, enlarge is a large size. Okay, all right, that is dilations. So to enlarge, you multiply some number, right? If you have a 2A over here, this length is over here. You want to make it twice the length, you need times 2. Or this one is a large one, original, that we set pre-image. Okay, now the image is getting shrink over here. By this time, we multiply, it's a half, it's a 1/2. All right, this number is called scale factor, or someone said dilation constant. Scale factor or dilation constant, not factors. A factor, you can use factor, but usually this is a formal name is dilation constant. Dilation constant sometimes greater than 1 enlarge, some other times less than 1 shrink, and sometimes equal to 1. It doesn't change, right? Okay, the size doesn't change, same as before. In this case, special name is we said congruent. All right, but when you enlarge or shrink, well, this is not congruent. But in this case, they change their size. So between these two figures, there's some relationship. What can I say? They are similar. Okay, in this case, we said the figures are similar. They are similar figures. LAR, similar figures. Okay, so you have to find, okay, what's the difference between congruent and similar. Congruent is what a scale factor is 1. Scale factor is not 1. That is, they are similar figures. So, and also a dilation constant or scale factor cannot be negative 1 or cannot be 0. So I'm going to use this. Usually we use K. K must be greater than 0 or less than 1, or K is greater than 1 or K is 1. Okay, we have 3 different scale factors there. Okay, so when you make, oh, this is, we have a lens, magnify lens. Okay, when you put this on this triangle, enlarged, that's right. So when you have enlarged, they can make, over here, they want you 10 times enlarged, okay, the original side. So each corresponding side, 3 times 10 is, this I'm going to use very small. This is like 3, 4, 5, not very big. 10 times scale factor is 10 times corresponding side. This side, it should be 30 The other side is 40. This is the hypotenuse is what 50 in large, but they are similar, right? Because what every corresponding side, where is the corresponding side of this one? This side and this side, they are corresponding side. Always what? 10 times in large. This one 10 times, yeah, this side, corresponding side, hypotenuse, and this hypotenuse corresponding side. Okay, so they are similar, right? Similar definition is what? All corresponding side, or corresponding side are proportional or are in proportion. In proportion means for every corresponding side, this one times 10. If they have different scale factor, this one is times 10, the other one is times 15. But in this case, we don't say they are similar. Okay, right, that's the point. Okay, what transformation is being represented by this description? What transformation? What is the name of this transformation? Make large or make shrink? It has its own name. What is the name of transformation? We said dilation. Okay, I'll give you, I think you guys learned this already. Transformation. Transformation is change their location. Sometimes change their size. That's it. Okay. The first one of transformation, we said translate. I'm going to use this triangle. We're going to move here and down over here. This is we said translation. Move to the right and move to the down, or move to the left and move to the up. You said translation. Use it right. Second one is line reflection. This is one of the right transformation. Line reflections, we can use this one in the y-axis. That is the line reflection. It's actually symmetry. Okay, this is we said reflection over y-axis. The next one is we have this one. When you have this triangle over x-axis, this is the x-axis. This is the y-axis. But in this case, graph looks like this way. Or any line, special line, okay? X equal 2 or y equal 2 or something like that. Generally, we use the y-axis or x-axis, okay? Or sometimes we use, okay, y equal x-axis, or y equals negative x-axis. This form, 1, 2, 3, and 4. I think you guys learned this already, okay? Now the next transformation is rotation. You're gonna rotate this one. Rotate. Oh, we rotate. Okay. And the next one is now dilation. Dilation is what? Already have the center. I'm going to take this center. If this is line or any figure, okay. You're going to make it twice. From here, make it twice. 1, 2, 1, 2. Okay. Yeah, this is dilation. A, this is A, this is B, this is A prime, this is B prime. Okay, there's a center over here. Okay. All right. But translation, line reflection, rotation, they are all what? Rigid motion. This is all together, we said rigid motion. What that means? Rigid motion, they preserve, right? All this transformation preserve the distance. Same distance, same distance. They're not gonna change, right? The shape and size. We said this is a rigid motion. Only dilation is what change the size. Okay? Dilation, not rigid motion. It's not rigid motion because it doesn't preserve distance. Is it okay? All right. Back to classwork over here. That is a dilation. You guys need to memorize the word. It's okay. Dilation. Okay, maybe you better go over right definition. What is definition over here? Dilation is right in. I'm going to write down over here. Okay, that is better. Okay, maybe you can use it enlarging or shrinking. Okay, and which one? Any figure, line or triangle or cube, anything. Okay, any figure by which one? By I'm going to use this one, certain scale factor, dilation constant. Okay, this is the definition of what dilations. Okay, in this triangle, only in triangle, I'm going to use, okay, any triangle is okay. Triangle or square, any figure, okay? It doesn't matter. This triangle, I'm going to, for example, triangle. When you enlarge, angle doesn't change. Okay, I'm going to make this small with this center, okay? Small. This is the same angle of this one. This is the same angle of this one. This is the same angle, 90. Okay? So in this dilation angle, I'm going to write down a bit. The first one is angles are same as before. We said use this one, congruent. Congruent means what? Same size, same shape. Okay, the only thing different is what is that? Second one is, what can I say? The side measures. When you measure the side, are in proportion, I told you, okay, are in proportion. Yeah, that is properties of dilation, okay? For example, so I'm going to use, okay, example is okay. I'm going to use, this is a 3, 4, 5 side of it. This is a right triangle, okay? 3, 4, 5 number is the side of a right triangle because you know that 3 square plus 4 square equals 5 squared. Okay. So I'm going to use this one. Okay. Let me see. I'm going to use some special angle because we cannot use, okay. We have angles over here, 53.1 degree, okay, between 3 and 5. Okay, yeah, we know that. So I'm going to make enlarge times 2, scale factor is 2. Every side is what? Increased by 2 times. This is a 6, this is 8, this is a 10. That is one of the example. As you can see, angles are congruent. Okay, angle doesn't change. Okay. Okay, the other one is non-examples. Because every corresponding side not in proportion. 3, 4. Maybe this one is 2 times 6. This is 3 times 15, something like that. Okay, that is not similar. That is not dilations. Dilation is a scale factor, always a constant number, same numbers. Okay, oh, this is maybe we better use dilation definition. So you guys figure out the definitions. So what's happening in there and some of examples. Okay, that is dilations. And you have any questions about this? Dilation. All right, dilation is similar, okay? In similars, there was dilation. Okay, what is the rigid motion? Oh, we did already, okay? Rigid motion. You know, rigid motion transformation, they preserve what? Distance, okay? Every corresponding distance. So maybe you can say, I think this is a better side length. Okay, and the next one is what is the rigid motion, and also what? Angle measure too. Okay, angle measure too. Angle measure. I'm going to say angle measure. Okay. So rigid motion always what? The figures same shape, same size, which is said congruent figures. That is okay. That is rigid motion. Remember, preserve distance and angle. Everything preserved. Okay, we have a translate. When you move this translate, it means what? Change location, right? Change location. Every point change same distance. This is line, this line, same length, same directions, same directions, same directions. So same magnitude, same direction. I'm going to write down the same magnitude means same length. And the arrow is what is that? Same direction. So we named this line is vector. Vector has what? Same magnitude, same directions. Vector has direction over here. Magnitude and direction. Okay? But it's going to be same vector. That is translate. The next one, reflect. This is a line reflection. Over this line, they change their locations. Okay? We reflect over what? This is the lines, line reflections. It can be y-axis, x-axis, y equals x-axis, or y equals negative x. This is rotations. The triangle said changed. No, it had same size, same shape. Okay, all right. We rotate this one, okay, around what? This point. This is we said center. Okay, all right. So we can use one around point. Okay, by a certain number of degrees, it should be same measurable angles. This point move up here, this much angles. This point move up here, this angle. It should be same measure. Okay, yeah. So we can say a certain number of measures. In this case, I'm going to use degree. Okay, degree is better. You can use right clockwise or counterclockwise, it doesn't matter. There is rotations. As you can see, the figure have the same length, same size, same shape. This is we said rigid motion. Remember, translation, translate or reflection, and rotation. All this one keeps what? Preserve their distance, everything. So this we said rigid motion, but dilation is not rigid motion, okay? You guys have any questions about this? First one, what is the rigid motion? You have to define this one, okay? Rigid motion is what is that? Preserve distance, angles, everything. Usually we set preserve distance, okay? If they preserve distance, angle automatically is same, okay? I'm gonna write down. When they preserve distance. This is the main idea. If preserve distance, or other one is preserved, okay? All right, dilation also transformation, but a little bit different, okay? Dilation preserve what? Not length, only what? Angles, okay? Only angle. This angle, same measure. This angle, equal in measure. Angle C prime equals. Okay, only this will preserve what? Angle measure. But what about side? The length? No, they don't preserve. They're gonna change it. But change, we better use side length. Okay, all right. That produce what is that? Change the side length. We said the figures are similar. Okay, the figures are similar. So they produce what? Similar figures. I'm sorry. AR is better. Yeah, similar figures. Because they change the sign with the same angles, the resulting figures should be similar. Okay, all right. Already when you have a dilation, change their size. They have a center over here. This is we said center of dilations. Center can be anywhere. Anywhere. You can, center can be on this over here too. Okay, for example, if we have a center over here, scale factor is 2. What is the image from this center? A prime should be at same point. It doesn't change. This is centers. This is A prime. Where is the B prime? B prime from center increase twice. 1 and twice. That is B prime. When you have right AA prime the same point, that's the center of dilation. This one from here, make it enlarged by twice. 1 times, another 1 times. This is what C prime. When you make the line, this is similar, enlarged what? 2 times. So center can be anywhere. How can you find the center? Okay, make the line over here, right? Any 2 points is okay. We don't need to write 3 lines because all 3 lines intercept at 1 point. Just 2 lines is enough. I'm going to use this line and the other line over here. When you extend the line, you will have some intersection out there. That's the center of dilations. That's easy to find the center, right? Just to make a line. But when you make a line, you have to use a corresponding point. A prime. B, A, that is not the line, okay? All right, but this is not good. Okay, now we're gonna dilate. about what? Always a center, isn't it? From here, you're gonna dilate, enlarge, or shrink. I'm gonna do center of dilation. Exact name is center of dilation. By what multiplier? We multiply some numbers greater than 1 or less than 1 or sometimes equals. What is the name of the multiplier? Scale factor, okay? Usually we use the letter K, little k. You can use anything, but in mathematical rule, formal letter is K. You can use A, but that is not a good idea because what? Mathematics, they want you to use K for the what? Scale factor. Maybe if you use the A is 1, A is 3, maybe someone think right out there. Take time, what is the A, right? If you use a K, oh, that is dilation factor, scale factor. Everyone know that. Okay, now summarize one more times. If scale factor is 1, the figures will be what? The resulting figures enlarge. I'm gonna write down. Okay. Write one more, okay? Enlarge, okay? Now is better, enlargement. K1, what is it? Congruent, you can use congruent or stay same. Okay, on with the stay same or congruent. And K-dilation, well, but it can be negative, right? I'm going to write down scale factor cannot be negative. Okay, you got to be careful. Already greater than 0. Okay, but in this case, shrink or reduction. You can use that either of this one. All right. Okay. Now we're gonna have some examples there. All right. We have a vertices of triangle JKL have coordinate 5, 1, -2, -3, and -4 and 1 on this XY plan, under which transformation is the image not congruent. We know the right transformation. One of them is translate, line reflection, rotation, and dilations. There are a little more, but you don't need this one right now. There's the glide reflection, point reflection, but you don't need this one. Only what? The major transformation is, you have to memorize. What is that? Translate, line reflection, and rotation, and dilation. This is the main transformation 4, okay? Out of this one is what? All 3, translation, line reflection, rotation, they're all rigid motion. Rigid motion, they're all congruent, same shape, same size. Only what? Dilation is not congruent. This is dilation is okay, but scale factor still 1. This is congruent. It's nothing. This is actually not dilation, but someone still, okay, scale factor is 1, also dilation, but best special case. But this is a congruent. Okay. All right. Anyway, this is congruent, not dilation. This is a rotation. They are congruent. rigid motion. The shape, size doesn't change. Reflection over x-axis, this line reflection, still they preserve distance. That is rigid motion. The next one is about dilation, and also a factor is not 1 anymore. Factor is 2, enlarge it by 2 times. Center at any origin. Okay, any point is okay. Center can be any point. Yeah, this one, they are not congruent. They are now similar. Okay, so the answer is 4 is the answer. Okay, try number 2. We have 2 figures. Image of this one. This is we set original, we set pre-image. Original image. And after transformation, we got the image now. This is a new one. Under which transformation where triangles not be congruent. Not be congruent means what? Change their size. Change in size. That is dilation. So we're gonna check it out. Reflection, no, line reflection, they are congruent, which is a rigid motion. Dilation, yeah, this is a change because of factor of 2. But if this is a factor of 1, that is congruent, not changed. Translate is move their location, still they preserve, right? Okay, that is a rigid motion. Now the next one. Oh, this is a dilation 1, especially this is we said congruent. Okay, so the answer is 2. Yeah, anyway, today's topic, there were dilation. So maybe dilation is the answer, I think. All right, we have 2 triangles there. ABC and DEF, they are similar. They must, similar means what? There have been some dilation there. And also, they have a taken over here. Auditor, already different, right? This is moved to the right over here, rotation, right? There must be some rotation too, isn't it? There must be some rotations. First, we can find, okay, scale factor. Check out their corresponding side. This 4, this 8, this 4 corresponding side, because this angle is 90 degrees. So this one move over here. So scale factor K should be equal to 1/2, isn't it? Okay, all right. So idea, the best idea to map, right, this one, this is right pre-image to the image. The best idea, you can rotation first. When you rotation, this one is up here. This one move over here, looks like this way. Okay, that's better. When you rotate, looks like this way. Okay. So which way we rotate it? Count clockwise or clockwise? This way is count clockwise. We use a positive. Count clockwise. And to the right side, this is about clockwise. Okay, that is used about minus. Okay, count clockwise is we said 90-degree rotation plus 90-degree rotation. That means what? Count clockwise 90 degree minus 90-degree rotation is what? Clockwise 90-degree rotations. But this one is clockwise. How many measures? How many degrees? 90 degree. From here to here, 90 degrees. Okay. Which one gives us what? clockwise 90 degrees. This is a counterclockwise. I don't think so, right? This is a counterclockwise. No. Rotation 180. I did wrong, right? ACE is original. This is their pre-image. I did wrong. Sorry about that. I did it right the other way. From here, you're gonna make this one. Okay, I'm sorry. And this is pre-image. EDF is what? Image. This is what center of rotations. Okay, when you make the line over here, this line, okay, they are intersection over here, okay, that is the center of rotations. So anyway, 90 degree counterclockwise. This is a counterclockwise 90, counterclockwise 90, not 180, 180 too much. After that, this figure looks like this way, red over here. This is A, this is C, this is also what? E prime, isn't it? They use ABC, AEC, okay? I'm going to this is what? A prime, C prime, E prime. After that, we need what? Shrink. Okay, we need to shrink. No, not shrink. From here, we're gonna make it enlarged, okay? Sorry that. Okay, what I'm doing. This is original, okay? Now you're gonna make enlarged. How can you find the scale factor? You can use any corresponding side. You can use this 4. This is a corresponding side. 4 change to 8. So 8 over 4 is what? 2. That is a scale factor, okay? That's a scale factor. Or you can use this one too. 3 change to 6 times 2, right? You can divide. That's it. So scale factor is 2. Okay, so I can see scale factor over here, 2 over here, okay? So choice 4 is the answer. That's the correct one. All right, now everybody try number 4. The image of ABC. ABC, this is pre-image. This is now after transformation, after dilation, right? Actually, that is a dilation scale factor K, centers at 8. This is center. I'm going to use this one. This is the center. They enlarged. This original enlarged times some scale factor, right? Enlarged. So AB, AD, right? AB, AD corresponding side, BC, D is corresponding side, AC, and AE corresponding side. Okay, using this one. And also these two figures are similar, right? Because there was what? Dilations. All right, which statement always true? This one already twice, we don't know, 2 times or 2.5 times. We cannot say exact 2 times, not always true. Because they didn't say scale factor K equal 2. It's just what generally what K. So K doesn't have to be 2. This is a little weird, right? Again, not always true, okay? Not always true. AD DE perpendicular, AD, and DE. It is perpendicular. They said this is a right angle. This is a right angle. No, they didn't say anything about the angles. It looks like a 90 degree, but it's not. We cannot say they are perpendicular. Okay, this one, we cannot say this one, right? So not enough information. AC equals CE. Now this is twice. No, we don't know. If K is 2, twice. This is twice, then these two lengths is equals. But this is generally just K. It doesn't give any specific numbers. This we cannot say always true. What about BC and DE? BC and DE, it doesn't matter, okay? How measure of this length, the other side of length, we don't know. But the only things we know that what they are parallel, right? They are parallel. Okay. Why this is a parallel? Because we know that similar, this angle is actually equal to this angle. Angle doesn't change. Angle still preserved. And this angle equal this angle. Okay, because they are similar. Because you know that parallel line and we have a transversal. These two angles are corresponding angles. If the corresponding angles are equals, these two lines are parallel. That's the formula, isn't it? If corresponding, okay, when you have a right parallel and transversal, okay, over here, if corresponding, angles are congruent, the lines are parallel. It's just simple. So this is already true because we know that this angle and the other side angle are equal because what they preserve angle. Okay, angle doesn't change. Are you guys with me? Yeah, that is number 4. All right, a little more, we need a construction over here. Finding the center of dilation. We did already. We're gonna use 2 lines, because what? 2 lines is enough. Because all other line anyway intersect right the same point. Okay, so you choose 2 lines to find what? Center of dilation. Okay. All right. Oh, they already got over here 2. Draw 2 lines. So 2 pair, that's enough. Not, you don't need a 3 pair, okay? You have 3 pair. So what I got next? Make the line over here, AA prime. This way. There's no intersection the other way because this is small. Always what? Smaller figure is close to the center. Center is always what? Smaller size. Okay? All right. So make another one over here. Yeah, that is intersection. This is the center of dilation. And okay, so what can you say over here in the blank? Better is what? Intersection, right? Intersection. Intersection of these 2 lines is the center of dilation. Okay, now this is another formula over here. How can you find the scale factor? Scale factor always a new over any corresponding side. you can use what this length. This is what new old one. This is a new. New is this time will shrink. You can any corresponding size. This side is new. Maybe I'm going to this is a 1, this is a 2. So 1/2 less than 1 shrink. Or you can use this corresponding side too. Or you can use this side too. It was before we are to the center. That is too much. This is what. Okay, I'm going to use. Okay, all the way distance. This is new distance. That's a corresponding side too, right? Also, this one considered as a corresponding side. You can use this number too. Okay, if from here that is a 3, this is a 6, still 3/6. Okay, because we use what 1 to 2, right? Shrink by half, isn't it? That's why I use what half of this number, 3. So K should be obtained by any corresponding side. It should be a ratio, right? New number, new measure over old measure. Okay, so we're gonna memorize this one, okay? All right, from this topics, how we find center of dilations. That's the first topics. Second one is how we find the scale factors using any corresponding side. But the ratio should be what? New over old. All right, new distance over old distance. Okay. The next number B is the scale factor between 0 and 1 or greater than 1. Less than 1, right? Because what A, B, C is pre-image. Usually A, B, C pre-image, we don't use what prime. Okay, this is old. New one is we use the image or you use this symbol A prime, B prime, C prime. More new. Transform again, you can use what second prime, second prime, second prime. This is the new. But in this case, you can see the figure is smaller than before, right? The scale factor should be what is that? Between 0 and 1. Why? Why is it between 0 and 1? I told you, right? The image is smaller than original. That's right, that's the reason. Okay, or you can write down because. That's a perfect answer. Okay, the next one. What is the scale factor with the corresponding side? How can you find the scale factor? I told you already, any corresponding side, you can use it. You want to use this side, this old one, this is new one, sorry. A prime, C prime is what? The measure of this length. Over corresponding to this one, all the one corresponding AC. When you find the ratio of this one, that is scale factor. You can use this way, any corresponding side. Or B prime, C prime over BC. Or A prime, B prime over AB. You can use anything. They have the same scale factors. And also you can use this one, OA, so all the way is what? OA prime over all the way is OA, right? This is also same thing. Okay, you can use distance from the center, right, to the any vertex. Okay, we just did I will find the center of dilation, and I will find the scale factor using any corresponding side. All right, number 2 over here, determine the location of a center. Oh, we know that already, okay? This is just new one. This is what? Old one. This is a new one. Make the line. I'm gonna make the line over here. Wow. Okay. We did find, okay, over here. Okay, I'm gonna use, let me see, I'm gonna use some line over here, that is better. I'm gonna do this line from here to your B prime B. A little longer, this much enough. Okay, this much enough, I think. Yeah, that's right. The lines pass through to what? 2 corresponding point, B and B prime. Now you're gonna do A. You can use A, but better you just C, because A is too close with the line B and B prime, okay? But better looking, we better use this line. Oh, very close, right? Yeah, we have intersection up there. All right. So this point is center of dilations. Okay, center of dilations. So which one is old? This is old. This is right old. This is pre-image. This is the image. That means what? Dilation will be enlarged. Okay, right. So in this case, over here, scale factor should be greater than 1. Because what? Because what? I'm going to, because you can say, right? You have to say the reason, okay? Because what? The triangle, image of a triangle, or the image of a triangle is better. It's bigger. That's why, not strength. That's just scale factor is greater than 1. What is the exact scale factor? Oh, to find exact number, we need what? Corresponding side, any corresponding side. You can choose this corresponding side. I'm going to use this corresponding side, that's better. Which one is new? This is a new one. So 15 over old one is 5. New over old. This is 3. So scale factor is 3. Okay. So from here we can say K equals 3. Any corresponding side too, if you want to use this one, 12 over 4. That is 3. Oh, you want this one? 16.5 over 5.5 is still 3 because the scale factor doesn't change. Okay, that's why sometimes we said dilation constant. What do you mean constant? Constant doesn't change. Okay, scale factor is constant. I'm gonna write down. Between any corresponding side should be constant. Any corresponding side should be constant. Now we can say it is a scale factor. If they have different numbers, we don't say scale factor, okay? All right, now 11:56, we're gonna have a 10 minutes break, okay? So everybody come back here, 12, this is 11, right? 10 minutes, 12 or 7, up to. Everybody come back here, 12 or 7 p.m. Okay, 10 minutes break. Okay, all right. I'll show you in 10 minutes. Thank you. Okay, now back to work. And I'm gonna tell this, okay, the lecture is recording. Okay, if any of you need the video tapes, you let me know, okay? I'll send out the link. So this lecture for the time being, it will be posted on YouTube, okay? So using the link, you can see the video if you want it, okay? You let me know that. Oops, where is it? Okay, just a minute. I'm gonna make it a little big. Okay, all right, take a look. This is number 3. We're gonna find the center, right? Dilation, center of dilation. Okay, we know the rule. Okay, how you find the center of dilations using 2 corresponding vertex. If when you got to anything, any figure is okay. It doesn't have to be always triangle. Okay, always what? Dilation, center of dilation, the intersection of any 2 lines. If you choose 3 lines, it's going to be same section, same point. If you use 4 lines, same section. So you don't need to write more than 2. Okay, just 2 is enough because it has the same point. So inside, when you take a look here, the triangles inside there is pre-image, original figure is inside. So where is the center? Center should be inside. Okay, center should be inside. You might guess. Or let's make it by the rule. This is the point. This is corresponding point. Make the line extended. Maybe that's enough, right? I think it's better. This is enough. Okay, a little extend. Yeah, that's the point. That's the line. All right, I'm gonna use C prime. C is okay too, but instead of these 2 points, the better looking, I'm gonna use B prime B. That is better looking, right? Okay, I'm gonna do that. E prime and B. We already got the inside there. That's it. Okay. Also, you can use C prime C. It doesn't matter. Okay, I'm going to use my C prime C also. Can you see that? Intersect the same point. Exactly same point. Okay, so that's why we need only 2 lines of intersection. Okay, that's fine. So where is the center? Yeah, the intersection is the center of here. This one is, oops, too thick. Center of dilation. Okay, you can construct. Okay. All right, it's a scale factor between 0 and 1 or greater 1. You can take the images enlarged. It should be greater 1, right? Greater 1. But because JUSC. Because what? The image is bigger. Okay, enlarged, or you can say enlarged. There's no doubt. What is exact scale factor. Oh, to find the scale factor, we need the measure of two old one and new one, any corresponding side. You want to use this hypotenuse? No, hypotenuse is what? We cannot measure this one. We can do that using Pythagorean theorem, but you don't have to do that. It takes time. Any corresponding side, horizontal or vertical line is better. This one up to here, we can see that measure that is intersection over here, right? 1, 2, 3, 4, 5, 6. This is a 6 unit. Where is the corresponding side? Here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That is 15 unit. This is corresponding side. All right, so which one is new? This is new. This is old. Old is a pre-image, original. So K can be the ratio of these two numbers, 15 over 6. But you need to simplify. Always, okay? When you divide it by 3, 5 over 2. Or you can use decimal, it's okay, 2.5 times. Sometimes we prefer use this number as decimal instead of what fraction. Okay, that is our mathematical, formal use. Okay, we use this number decimal for the what? Scale factor. All right, now where is the location of the center? Can you see that? One side is overlap over here. The other side overlap over here. Where is A prime? We got A, B, C there. Where is A prime, B prime, C? Oh, we can see B prime, C prime there. Where is A prime? Because A prime is over here. Because the center is at this point. That's why A prime is the same point. Okay. And another property is what is that? When you choose one vertex as their center, these two sides is what? Collinear. Can you see that? Center is different. These lines not collinear. All right. When you're over here, these two lines on the same line. Okay. All right. That's different. So anyway, you can use these two lines, C prime, C. I'm going to construct using the definition. This line, I'm sorry. I'm going to use the line over here. From here, C prime, C. Here. And B prime, B. Here. Yep, that's the center. I just find the center of dilation using definition. This is the center. Dilation. Okay. All right. The scale factor, check it out. Enlarged or shrink. Enlarged, right? A prime, B prime, C prime, the figure is what? Bigger than original. Okay, so we have to write down over here, K must be greater than 1. And okay, the original you can write down now, okay? Okay, I will write down. Image, you use anything. It enlarged, it get, or this time you can use, someone use this, but gets bigger. Or is bigger, or is enlarged. You can just write any of this one. What is the just scale factor? We need to write dimensions, any corresponding side. Don't use, okay, this side, hypotenuse. Better use this side, horizontal line, or vertical line. All right, old one is how much? 1, 2, 1, 2, 3, 4, 5, 6. The corresponding side to the what? Old one. And a new one. How much? 3 more. 9, isn't it? So scale factor now new over old, 9/6. You can use fraction, but better use decimal place 1.5. Okay, either is okay, but this is a more popular expression for expression of dilation factor. Okay. All right, now let's move on. Okay, any questions about this up to now? No question, right? Okay, very good. Oh, this is your homework. I think so. Oh, we finished earlier. This is your homework. Let me see. Just give 1 minute, okay? This was your homework. Okay, but the other one. Just give 1 minute. Only this one. Okay, this is the lesson 2. All right, so we're gonna do this one now, okay? Okay. Let me think. All right, I'm gonna reduce this one. Okay, this was your homework, okay? So there's no pages. You can see that over here, okay? Unit 5, lesson 1, homework over here. How many questions? 1 to 5. Okay, 2 pages, okay? After you finish this one, send your answer to your teacher, okay? I think a teacher need to write this one, I think. Okay, now we go second work. This one. How many questions are there? They are similar, okay? It's very simple. They are dilated, okay? They're gonna change. Okay, now try this one. Just 1 minute, okay? Okay, that's fine. All right, now let's do this one. So we're gonna summarize one more time. What are the properties of a similar triangle? You already know that, right? Angle doesn't change. Only what? Side length will be changed. Okay? You can see this angle, corresponding side, this angle equals this angle is equals. Okay? Every angle is preserved. It doesn't change. All right, did you say about similars? How to think? This is a 47, 47, 47, 47. But this one is what? 33, 33, 47, 47. The angle, they are preserved. What about the side? What about the side? Any corresponding side in proportion, right? But this side, they just shrink. But this is not shrink. Is it okay? So they are not similar. It can be similar. Is it okay? But they're gonna keep the same angle. How? Move this one a little inside. This angle this because they are parallel. You can keep the same angles as before. But angles is okay. But similar is what it is. Side lengths should be in proportion, right? Any corresponding side in proportion. Must be in proportion. If this is not true, they are not similar, right? Okay, you can keep the same angle, move inside of here, still all the angles is the same as before, right? Because they are parallelogram. Okay, all right. So, how can you say this one? You have to say no. Okay. The reason what is that? Correspond between any corresponding side, there's a scale factor. This one scale factor to how much? 33 over 47. This is a scale factor how much? 47 over 47 is 1. This was a 32 over 47 is less than 1. They are all different scale factor. So we cannot say that's a scale factor. Okay, so maybe you can write down no, because what? The scale factor maybe you can say not the same for corresponding side. Okay, better memorize the word over here. This is the perfect region. Okay, maybe if you explain why this is not similar, maybe you can say because the scale factor not the same or scale factor for any or corresponding side not same. You can write down. Okay, that is perfect. Nobody object anymore. All right, what is the region motion? Region motion is the same size, same shape. That we said congruent figures. I'm going to the word over here. Congruent. Usually use this symbol. Okay, congruent. What that means? Similar but same size. This we said congruent. Usually this one is similar, right? Same size. All right. So corresponding side and angle measure are, what can you say? The measure. When you measure angle and side, they are all equal, right? Yeah. We don't say congruent right now, okay? Because this is the measures. Measure. When you measure, the side is actually equal. So we have to say equal. This one is what the length of the side. We don't know how big is this one. If we measure, you can use this one now. There's no bar over here. This is what they have some number measure over here. Okay, this is one measure. Is okay. This is angle A. Oh, this is angle L. We don't know how big is this one. When you probe here, measure. Now you have to say, oh, this is a measure. When you measure this angle with your protractor, it will be 80 degrees. Now this is a correct expression. Okay? Not this one. This is incorrect. When you measure means it has a numeric number. This is a correct expression. All right, dilation produced the figure. Dilation, similar, CJ, same definitions. This is just similar figures. Corresponding measures, corresponding angle measures are, measures is what is that? We said equal is better or congruent, but this is the measures are equal is better because we measured already. They have some numeric numbers, but corresponding, what is it? This is we need this one, okay. But corresponding side measures are, because this is a similar, what is that? In proportion. Okay, the next one is corresponding also proportion. Which one? Corresponding, the next one is what is that? Oh yeah, they said perimeter. Any length corresponding side. Perimeter is also length, right? Corresponding side, okay? This perimeter, the other side of perimeter. Okay, you can say this, you can just use one perimeter too. Corresponding perimeter also in proportion. So this is the perimeters share the same scale, okay? I'm going to do the 3, 4, 5. Perimeter is 12. 3 plus 4 plus 5 is 12. Now I'm going to make it enlarged twice. This is a 6, this is 8, this is 10. Any corresponding side right increased by 2 times. What is the perimeter over here? 6 plus 8 plus 10 equals 24, right? Also, perimeter is increased by 2 times with the same scale factor because they are corresponding side, perimeter, perimeter. Okay, so corresponding perimeter also in proportion. Okay, that's the reason. All right, now we have 2 similar triangles, ABC and DEF. Okay, now let's identify all corresponding side and angles. AB, DE corresponding side. That's true. Where is the corresponding side of DF over here? This one, AC, right? You can write down AC. Take this first. DE, this is DE, over AB. This is first, this is second. EF corresponding side, where is it? BC is now corresponding side. Okay, you can check it out. What about AC over BC? AC, where is BC? Oh, this is not corresponding side. Wow, what happened? This is not corresponding side. AC, BC is not corresponding side. This is wrong, but that's true. We can use this too sometimes. This is reset the relative side. I'm going to use the exact name over here, corresponding relative side. We said we're corresponding relative side. Oh. Relative. All right, up here, right? Okay, you can use sometimes the ratio AC over BC. This is corresponding relative side, relative. They are relation over here. Take this is the first and BC is the next in the same triangle. What is the other one? DF, this is first, this is second. This is the first, this is second. Second is over there, first is DF. This is also y equal to. This is we set corresponding ratio relative side. Usually we don't write down over here. Just what relative side. Because what when you multiply over here, it's actually same as before. This one move down. They can switch any times. AC over DF is move down over here. BC is going up, and EF over here. It's same as before, right? AC over DF equals BC. Okay, I'm going to do it. AC over DF corresponding side, isn't it? And BC over EF, that's corresponding side. But sometimes we use, okay, relative side. They can switch any times. Is it okay? So we have 2 different ratio. If you want to use corresponding side, you can use corresponding side. Or if you want to use one relative side, you can use the relative side. It doesn't matter. So here, AB, I'm going to use many tables right there. Okay, I'm going to use this one. AB and BC and AC. Corresponding side divided ED. AB or D is better. A is first. BC is what? EF. And the AC is what? A is first, C is second, that is better, right? DF. You can use FD, but better you keep the right same order. DF, that's the corresponding side. Okay? So the side usually, this is a measure when you use the ruler, you can measure, right? But it's okay. Also, you can use this one too. We don't need to measure anyway. They're going to have the same length. I don't know, corresponding length. Okay. Before measure, we use this symbol because that's similar, right? They're not equal. But angles is always equal, right? Angle A congruent, angle D. Or you can use a measure by angle A equals measure by angle D. You can use this symbol too. The next one, congruent means what? We don't know the exact number. Anyway, they have the same angle. Okay, that is congruent. Use what this symbol. After you measure the angle, use your protractor. Now you can use this one, measure angle, because it's already a number. Okay. The next one is angle B. I'm going to use what congruent, okay, before measuring. Angle B is actually equals to what? Angle E. Now angle C congruent angle F. Okay. All right, now we're going to have some algebraic solution over here. Using the algebra, you're going to find some missing side or angles. In this triangle, that's similar. Angle C is given by over here. This is angle C. And the angle G is given over here. We know that they are equal because they are similar. Any corresponding angles are equal. Okay, now they are equal. Find out the value of x. 4x plus 30 degrees equals 5x plus 10 degrees. They must be equals because they are corresponding angles. So minus 4x, this is the x. Minus 10 and minus 10, this is out. 30 minus 10 is 20. So the measure, the value of x equals 20 is the answer. Okay. Now the next one. I'm recording, right? Yeah, recording. Yeah, we have two similars. This is they said similars and 100 degree and dilation. We have two transformation. This is we said composite. Okay, more than two transformation. All right, count clockwise. This is pre-image. This is pre. This is image. You're gonna make the line count clockwise. Count clockwise, where is it? I don't know. Clockwise. Clockwise this way. Around 180 degree. 180 degree, okay, from here, right? Maybe you can use this one. She's over here, right? That's right? Okay. So it looks like this one. $100 over here. There is some center. Okay, you can use any center, okay? You can use 100 degree. It looks like this way. C is over here. A is over here, same thing. And the B prime over here. This is 3. This is 4.5. Okay, that is 108 degree, right? Clockwise. This is 180. That's fine. Okay, AB is 3, BC is 5.5, AC is another 4.5. Now you can see FD is 9, and AB is now 3, and FE 5.5, same as before. Okay, now which relationship must always be true? What is that similar is what? Scale factor for any corresponding side must be equal, right? Angle is always equal. Angle cannot have some number, or the angle is equal. This is wrong. This is wrong. This is wrong. This, oh, okay. Measurable angle A equals measurable angle D, right? That's not corresponding side. What about probe here? Measurable angle B, measurable angle E, corresponding side. Same angles. Okay, when you measure this one, same measure angle divided this is 1, isn't it? What about C? C is this angle, F is this angle. They have the same measure, same numeric numbers. They do 30 degree over 30 degree equals to 1. They are always equal. What that means, what is that? The corresponding angles not changed. That means what? Corresponding angles equals 1 means what? Not changed, okay? Have the same measure. Okay, so this is always true. Okay. All right. Now they are similar. They said they're similar. What is the value of A, B? Corresponding side are in proportion. First one, you can use this one, corresponding side in proportion. 7x, this is corresponding side, 7x over 7 equals. The next way, there's the order, right? This is the first, this is second, this is the first, this is second. Always keep the order. 4 over x corresponding side. When you cross multiplication, 7x squared equals 28. X squared equals divided by 7 is 4. X equals what? Plus or minus 2. X equals only positive available, right? Because there's no negative distance. I'm using a corresponding side in proportion. I'm going to do the second one. Okay, I mentioned already a relative side. Relative side in proportion to. What is that, right? In the same triangle. 7x over 4, that is the relative side. They are related this way. 7x over 4 equals the other relative side. Same order, 7 over x. This is relative side in proportion. You can use this one. When you cross multiplication, 7x squared equals 28. Same as this one. So anyway, the result will be equal, x equal 2. Okay? Maybe many students, they like or use a relative side. That's the easier way, this one, this one. If you use a corresponding side, this one, okay, this one, this one, this one, okay? But you can choose why anything if you think that is convenient for you. Okay, now we apply these similars to measure some unknown numbers. But if one side is you got the one side is known, the other side we can find it, right? All right, this side is 0.008. This is about 0.6. Okay, this is the angle or what? Let me see. Yeah, that's not angle, right? Inches, something like that. Okay. Kind of inches, okay? Anyway, I don't know the unit. Anyway, the ratio is the same thing, okay? Corresponding side first, 0.05 now actually represent x. Now, from this one corresponding side from 0 to 0.08 to 10.6. There must be same ratio. Or you can use the same thing. 0.05 over 0.08 equals x over 10.6. Anyway, when you make a cross multiplication, 0.08 x equals 0.05 times 10.6. When you divide by 0.08, you got this one. That's the same thing. 0.08 x equals 10.6 times 0.05. That's what they have, right? Different order, right? Community property is going to have a right same output, same result. Okay, now let's find what these numbers. Okay, let's give me a minute. Zero point zero five times 10.6 and equal and divide 0.08. So this is 6.625. Okay, so x equals 6.625. All right, now let's find another one unknown number in similars, because we know that every corresponding sides are in proportion. They are similars. First, which side is a proportion? You have to check it out. You're going to find by L and M over here, x. You write down over x. This is solid side, then the corresponding side. And the QR is the corresponding side, the LM, right? But from here, we can find what 7 times 3 is 21, or 21 divided by 3, or 21 anyway, scale factor, but divide times 1/3 is 7. That's a scale factor. Maybe this is another way to find. You don't have to set up the all proportional here, right? Something like this one. Sometimes we can find the scale factor very quickly. And the corresponding side, that integer, we know that 21 is a multiple of 3, or 7 is what? 1/3 of 21. And the corresponding side is 1/3. This corresponds to 1/3 how much? This is 10, this is 1/3 is how much? 9. Okay? If you can find the scale factor, it is okay too. I'm going to use what scale factor from here to here. A equals 1/3. Okay, I just use this one. All right, the next one, same questions. All angles is what? Congruent, same measure. This side, same angle. Yeah, that is the corresponding angles. So where is 23? Maybe this side is corresponding? No. Take a look. Angle B and angle D. This angle side, this angle 23. This is what is that? This one is corresponding side of this one. We're gonna be careful, okay? Because this 23 is what? This angle 2 lines circle. These two corresponding side. This x is what? Is actually corresponding this side. It's okay. I'm gonna mark over here. This side is actually corresponding this side. And this side corresponding this side. This side corresponding side. Can you see that? No mark over here and one line. No mark over and one line. Now you can find the value of x, okay? So find out corresponding side. 14, which side is corresponding? 21. And we're gonna find what this value of x. Which side is corresponding of x? 24, not 23, okay? It should be 24. Okay, now let's find cross multiplication, or sometimes you can reduce these numbers. 14 divided by 7 is 2, 21 divided by 7 is 3. This is better. We know that 3 times 8 is 24. 2 times 8 will be 16. You can solve this way too, or you can use cross multiplication. 21x equals 14 times 24. Nothing different. When you divide by 21, you can simplify at this moment. When you divide by 7, that is 3, divided by 7, that is 2, divided by 3 is 1, 24 divided by 3 is 8, that is 16. It's nothing different. Okay, you can simplify before you multiply the numbers, or after that, later you can simplify. Each way is okay too. All right, number 7, that's similar. Now let's find AB. This length is x. I'm going to take this is x. DF, this is y. Where is corresponding side? Oh, there's no angles. We're going to assume, right? Okay, it's actually what this side, corresponding side. And this side, and this side, corresponding side. These two corresponding side. Okay, now let's find the x first. We already two numbers. These are two numbers already known. We're going to use this number. So 6.3 is x equals what? 13.33. By x to the what? Corresponding side is 1764. They have the same scale factor. They are in proportion. So 13.23 cross multiplication times x equals 6.3 times 17.64, but you need divided by 13.23, right? Now we're going to use the calculator, okay? 6.3 times 17.64 and equals, and divide 13.23, not 25, 23. How much is that? 8.4. Okay, that is the right rational numbers. Terminate, decimal terminated. 8.4. Very good. All right, the next one, y. Same thing. You can use the same ratio because you already know that. 6.3 over 13.23. Where is the corresponding side? This one and this one. 4.1 over y. So cross multiplication, 6.3y equals 4.1 times 13.23. After that, you need to divide by 6.3, right? 4.1 times 13.23 equals, and divide 6.3, 8.61. That is also a rational number. Excellent. Okay. That's the answer. All right, number 8. Wow. Okay, we can finish this one. Okay, this is another homework. Okay, lesson 2 homework. Okay, so we just have 2 questions. After this, we can finish that. Okay, we can do that. This is another homework. Okay, so don't miss your homework. All right, number 8. 2 triangles are similar. Okay. Yeah, you can make like 2 triangles, 3, 4, 5, 3 approximate, 3, 4, 5. And the longer side of large triangle, maybe longer side. Which is the longer side? This is longer side. They said what? Their corresponding side, okay? That means what? Corresponding side. This is changed to 18. Now we know that, oh, what happened? 6 to 18. There is what? Multiplier times 3, right? You can say scale factor 3. At this time, you can use this one. Because we already know that 6 changed to 18 times 3. That is corresponding side. So any side will be multiplied by 3. So this is 3 times 3. This is 9 corresponding side. This is 5 times 3. You can use 15. Or you can use a proportion too. If we want to, this is the x, this is the y. 6 over 18 equals 3 over x. From here, you can find the value of x. This is equals to 9, isn't it? You can use a proportion or you can use scale factor. I got you with me, right? Number 8, we did it, okay? Okay, now we're gonna find the perimeter. We know the perimeter also at 3 times, there's a corresponding side, okay? Perimeter also length of side. What is the perimeter over here? 3 plus 6 plus 5, 3 plus 5 plus 6. That is 14, right? It's gonna be 3 times. It's gonna be 42, but we're gonna check it out. P equals how much? 9 plus 15 plus 18, how much? This is 24 plus 18 is about 42, isn't it? Also what? 3 times, because perimeter also corresponding side. So what that means? If they are asking only perimeter, actually you don't have to find all other side, x and y, because we know that this perimeter how much? 365, how much? Perimeter is about 14. The other perimeter, oh, from here corresponding side, we know that scale factor is 3. Just what? New perimeter is 14 times 3, that is 42. You can solve it this way too, right? Instead of find what? Any corresponding side, 9 and 15. What is the last question, number 9? All right, scale drawing on new school playground. A triangle area each side about 8, 15, and 17. 8, 15, and 17 is a right triangle, right? You have to memorize. 8, 15, 17, that is the right triangle triple. Looks like a 3, 4, 5. Second one is what? 5, 12, 13. Third one is what? This one, 8, 15, 17 also right triangle, because what? 8 square is 17 square is, no, 15 square. 17 square is hypotenuse. 8 square, 15 square equals 17 square. That's true, because this is 64, this is 225, this is 289, isn't it? They are equal. Memorize all these numbers. We said triangle triplet. We said what? Right triangle triplet. Okay, memorize this one. Yeah, that is a right triangle. The triangle area located in playground has a perimeter is 8, 15, this is perimeter. Oh, this is rear, right? This is rear. This is what? Drawing. The rear is much, much bigger than this one. You know that? Much, much bigger this one. This is rear. Okay? The perimeter is 120 meters. This one is 17 centimeters. Okay? Okay, what is the length of it, the longer side? No. if the triangle area located in the triangle at the perimeter 120, oh, this is perimeter 120, right? This is the perimeter 2 is 120 meter. What is the perimeter of this one? 8 plus 15 plus 17 centimeter, right? How much? This is 23 and plus 17 equals 40 centimeter. Now using this one, we can find the scale factor. What is scale factor? Forget about this one. Just change the numbers. Okay. If this is centimeter, you can put over here meter. It doesn't matter. From here, scale factor equals how much? 3, isn't it? 40 times 3 is 120. Now let's find its corresponding side. This one will be times 3. Change the unit is meter. This will be 24 meter. What about this side? Times 3, 45 meter. Times 3, 17 times 3 is what? 51 meter. Okay, that's the answer. I just use a scale factor. Okay, if not, if you want to find this one, x, y, z, we find the scale factor over here. Okay, so you have to use proportion 8 to the x. Oh, corresponding side you got over here, 40 over 120 equals 40 over 120. You can use this proportion too. Now, if this is y, 17 over y equals 40 over 120. This is proportion. Well, this is z, 15 over z equals still 40 over 120. Okay, you can use this proportion too. But after you find out the value of x and y, x should be 24 meter, y is 51 meter, and z is 45 meter. Okay, sometimes we can use a scale factor because scale factor can be easily found over here. Okay, all right. Yeah, we are done our classwork, and the homework is for you. Okay, do not miss your homework. Okay, but the practice is very important. Okay, so always what the math should be completely understood. Okay, so if any of you have any questions, maybe next time you can ask your teacher in the class. Okay, any questions about this? Anyone, any of you need the video over here? Anyone? Tell me right now. I'm gonna send out the link. It's okay? All right, now let's finish today's lesson, okay? Thank you for joining the class. I'll see you next time, okay? All right, thank you, everybody.
Thank you.
Thank you.